Alright, to do this question, we're given 3 points on a plane. So part A is asking us to determine the displacement vector AB. To do this, over here I've prepared it. We do B minus A. So B minus A is 3, 4, negative 3, and negative 2, negative 3, and 3. When we subtract these, we should get something equal to 5, 7, negative 6. So that's part A. So that is now going to be carried into our second bit. So the second one is asking us to determine the vector equation of the line that passes through A and B. So to do this one, we're going to use the vector equation of the line R equals A plus KD. So as I was saying, the vector equation of the line, which is R equals A plus KD. So let's write that down if we can. R equals A plus KD. Now when we substitute back into this one, we've got A is negative 2, negative 3, 3. In our little brackets, negative matrix, plus K, which K is just K, and then D. D is the equation that we figured out for that vector AB just before. So 5, 7, negative 6. So that now becomes our vector equation for the line that passes through A and B. Now for the next part of the question. So two other planes P2 and P3 are given by x minus 2y plus z equals negative 5 and minus x plus y plus z equals 7. Oh wait. Wrong bit, sorry. So given vector AB times vector AC equals 42 minus 12 and 21, use this result to show that the equation of the plane P1 is equal to 14x minus 4y plus 7z equals 5. Alrighty, so for this one, we're going to use this equation just here, vector AP times n equals 0. So when we put this into, well, when we do the math, it's going to be x plus 2, y plus 3, and c minus 3. Times n, which is our new set of numbers that we were given for the vectors AB times AC. So the 42, the negative 12, pretend that's a 12, and 21. That looks like an 11 back there, but we'll deal with it. So that's going to equal 0. So for this one, when you do the math, we're going to expand the brackets, kind of like we do for other things. So we're going to write it out. 42x plus 2 minus 12. Now we can see it's 12. Y plus 3 plus 21 z minus 3. Now we're going to expand the brackets. So we're going to shut up, Dylan. Sorry for that one. Dylan's just Dylan. So we've got 42x plus 82 minus 12y. Negative 12 times 3 will be negative 36 plus 21z. And then 21 times 3 will be times negative 3 will be negative 63 equals 0. So for this one, we're going to obviously do our good old star bridge and take across. Let me just get a highlighter. We're going to take across these numbers here. So we've got, oh, that button does stuff. Let's pretend that's not it. We've got this one, we're taking this one across, and this one. So keeping all our terms of x on one side. So for this one, we're going to have 42, our terms of x, y, and z. 42x minus 12y plus 21C, which is going to equal, for this one, sorry, Dylan came back around for round 2. Okay, so from what I know, this should equal 15. Now, all of these seem to be divisible by one common factor, which if we divide them all by 3, we should be able to make the equation a lot smaller and finally equal 14x for minus 12. Not 12y, what have I done there? Sorry, it is not minus 12, it's minus 4. So for that one, let's just get rid of that. Minus 4y, and then 21 divided by 3 plus 7z equals 5. Now this is that equation back up here. Ooh, let's pretend I did not just write through that. That's the equation back up there, and so we have just finished that question. So, on to the next part of this. Alright, so now that we've finished question C, we're going to go on to question D. So question D is asking for that, question D states that 2 other planes, P2 and P3, are given by those numbers. Use Gaussian elimination calculations to show that planes P1, P2, and P3 intersect at one point. So for this one, we're going to write out, let's put on the pen. We're going to write it out as if we are turning it into a matrix, of which we are doing. We're going to put the little line down the middle. I'm going to go -5, -1, 1, 1, 7. So those are those 2, and then we're going to use that one from before. So the 14, the -4, and the 7, and the 5. Okay, now that we've got that done, we're going to use Gaussian elimination. So for this one, we can keep row 1 the same for now. We're going to do row 2, we're going to do row 2 plus row 1. Far out, Dylan. No, I don't know what I said because, once again, we had a Dylan. Okay, so for this bit, we're going to, where the heck is this? Okay, so for this bit, we're obviously going to use, what were they called? We're going to use some row echelon form. So if you wanted to do this in the calculator, you could do RREF. However, this one's asking us to use calculations. So for this one, for our first step, we're just going to keep row 1 the same. 1 minus 2, 1, -5. For row 2, we're going to do row 2 plus row 1, which will equal 0, -1, 2, and 2. For the third row, we're going to do row 3 plus 14 times row 2, which for this one is going to be 0, 10, 21, and 103. So now that we've got this one, have I pushed play? Yes, I have. 103. Okay, so now that we've done this one, we've kept row 1 the same. Row 2, we've done R2 plus R1, and row 3, we've done row 3 plus 14, R2. So now, can I scroll? Yes, I can scroll. Perfect. So for our next step, we're gonna keep row 1 the same again because why not? 1, -2, 1, -5. Row 2, we're gonna keep the same. So 1, 2, 2, and row 3, we're gonna do row 3 plus 10 times row 2. So this is all focusing on getting rid of those numbers to get the zeros, obviously, because that's what reduced row echelon form is asking for. Ooh. She's a bit hard to do, isn't she? So I'm going to write what I've done over here now. Row 1 stayed the same, and row 3, that's like row 3 plus 10 row 2. Now, our next step, we're going to keep row 1 the same again. We're going to do negative row 2, so 0, 1, negative 2. I forgot to write negative 5 back up here, but negative 2 goes over here. And then for row 3, we're going to do row 3 divided by 41. So row 3 divided by 41 is 0, 0, 1. So now that we've got that final row in... what was it? Now we've got the row of 1s and the 3 zeros down the bottom, which is row echelon form. However, the question asked for reduced row echelon form. I'm just going to write in what I've done here so that you guys can kind of see what's happening. Divided by 41. Okay, so there is more because we want those top little columns to be what we want them to be. So for this one, we're going to do row 1 minus row 3. So that'll get us 1 minus 2, 0, minus 8. And then, so that's row 1 minus row 3 for that one. And then row 2, we're going to do row 2 plus 2 row 3, which is going to give us 0, 1, 0, 4. Obviously, there's more than one way to do row echelon form, and it's down to whatever you want to do. But this is the way I'm going to do it. The next one we're going to do row 3. We don't need to touch because it's already in that form that we want. And you can see we've only got 1, negative 2 left. So to get that one down, we're going to do row 1 plus 2 row 2, which will give us 1, 0, 0, 0, 0, 1, 0, 0, 0, 1, 4, and 3. This is now reduced row echelon form. And we did nothing to rows 2 and 3, but we did do that. R1 plus 2 row 2, sorry. And then that means these values here, which if I can highlight them, these values here are going to be your new coordinates of that point that intersects. So it's going to intersect at 0x, 4y, and 3z. So that's the answer for that one. Alright, and now for the final part, we're asked to evaluate the reasonableness of your results for part D. So in part D, we obviously got the 0, 0, 4, and 3 for our values of x, y, and z. Now to find this one, we're going to do left-hand side equals right-hand side by substituting these results into one of our equations before. So for this one, I'm going to choose to do x minus 2y plus z equals negative 5. So for this one, obviously x is 0, minus 2, sub in y as 4, plus 3, which equals negative 5. If this is true, so for this one, obviously negative 2 times 4 is negative 8, plus 3, negative 8 plus 3 equals negative 5, which it does, and therefore its left-hand side equals right-hand side, so it must be correct.